You are listening to The Vocal Technologist. Spoken tech for your ears.
Wow. I swear, every time we sit down to look at what's happening in tech, the pace just feels, I don't know, completely vertical.
It really does. It's almost hard to keep track sometimes.
Yeah, this month alone, we're talking multi-billion-dollar chip deals, huge corporate strategy shifts, and somehow still finding time for robots folding laundry.
The laundry folding robot is always a highlight, isn't it?
It is. But look, it can feel overwhelming. That's why we've pulled together this stack of material. We're going to try and quickly but really thoroughly pull out the big foundational moves happening right now.
Yeah, the stuff that's really shaping the next few years, the underlying structure.
Exactly. Things like the operating system wars, the massive hardware builds. We want you to walk away feeling genuinely informed, cutting through all the chatter.
Let's do it.
Okay, let's unpack this.
Yeah.
So first up, what a lot of people are calling the new platform war. You know, the battle to be the Windows or the Android for this next wave of AI apps. It feels like OpenAI just made a huge play.
Oh, definitely. What's really interesting is how their strategy is shifting. It's moving fast away from just being, a powerful model in a chat window.
Right.
They're trying to become the central platform. That recent Dev Day, okay, it gave us cool things like Sora 2 and the Agent Kit, but it wasn't just about better models. It was fundamentally about distribution.
Yeah, they totally flipped the script on ChatGPT's role.
Huh.
They enabled third-party apps, big names too, like Booking.com, Spotify, Figma, Canva, to be right there inside the chat interface. That feels like a very aggressive land grab.
It is. And the mechanism, the how, is the really crucial bit for anyone building stuff. They launched the Apps SDK, sure, but maybe more importantly, the Model Context Protocol, MCP.
MCP, okay.
Think of MCP as the essential plumbing. It's what lets developers hook up their own external data, their proprietary tools, directly into the AI. Without that kind of protocol, you can't build those really deep, specialized functions that make people stick to a platform.
Okay, hold on, though. If OpenAI becomes this sort of central hub managing all these other apps and, potentially sensitive data Figma designs, booking info, what happens with security, privacy liability, doesn't that centralization create like one massive target?
That is absolutely the core tension when you build an ecosystem like this. It's a huge question, but for now, it seems the incentives are winning out. Developers want speed, especially with things like those priority processing tiers for the GPT-5 API. Apparently, they're running, 40% faster? That time saving is a massive competitive edge if you're building a business on their tech.
Meanwhile, you've got Google almost playing defense, right?
Yeah.
Fighting really hard to keep its traditional distribution advantages. They're insisting they should be allowed to bundle Gemini AI directly with things like Maps and YouTube.
Yeah, and that strategy is straight out of the old platform wars playbook. Google's basically arguing, and I'm paraphrasing a bit here, that putting Gemini into their existing products is just like Microsoft putting Copilot into Office.
Okay, yeah, I see the parallel.
They're saying, look, we own the map, we own the video site, we own the browser, so we have the right to integrate the AI layer there. It's about protecting their turf, their distribution points.
So OpenAI is gunning to be the new OS, while Google is defending the dominance of its existing OCs in a way. A real battle for who controls the front door for the next billion users.
Pretty much, yeah.
Okay, so shifting gears now. Let's talk about the sheer, almost unbelievable scale of the money pouring into the actual physical stuff needed to run all this AI.
Yes.
This isn't just software anymore, is it?
Wow.
It feels like a materials and energy battle now.
Oh, completely. And maybe the most eye-popping headline here is that massive AMD and OpenAI partnership.
Right.
OpenAI has apparently committed to buying 6 gigawatts worth of AMD chips, starting with the MI450s next year, mainly for inference, for actually running the trained models.
6 gigawatts, that number just hangs there. It's so abstract.
Yeah.
Can you put that into context for us, like compared to a city or something?
Is enormous. 6 gigawatts is roughly the generating capacity of 6 large nuclear power plants.
Wow. Okay.
It's a staggering amount of power. And that tells you not just about the scale OpenAI is operating at, but also how much energy supply itself is becoming a fundamental bottleneck for AI growth.
And for AMD, this must be a monumental win, right? I mean, cracking Nvidia's seeming stranglehold on the data center AI chip market.
It's huge for them. More than just a single win, it signals that diversifying the supply chain is now absolutely critical for these big AI players. AMD's big push, pivoting from mostly gaming and PC chips to really prioritizing these data center monsters. It's clearly paying off. They're a serious, high-volume competitor now. Nvidia has to be looking over its shoulder.
But Nvidia is definitely still the kingmaker, especially when you look at Elon Musk's XAI plans.
Mm-hmm.
Colossus.
Oh, yeah.
The first Colossus data center is already huge, and then Colossus 2, they're talking 550,000 chips, costing tens of billions.
And this is where the financing gets really interesting, and you see this almost symbiotic relationship. XAI raised a ton of money, yes, but Nvidia itself is investing up to $2 billion, a mix of equity and debt, specifically to help finance XAI buying Nvidia's chips.
Wait, that sounds a bit like self-financing. How does that work? Is Nvidia just giving them chips?
Not quite giving. It uses something called a special purpose vehicle, an SPV. Think of the SPV as a sort of middleman entity funded by investors, including Nvidia. This SPV buys the chips from Nvidia. Then XAI essentially rents those chips from the SPV for the Colossus 2 project.
Ah, okay.
Lets XAI scale up incredibly fast without having to bear the entire multi-billion-dollar capital cost up front. And of course, it guarantees Nvidia a massive locked-in customer. It's a pretty clever bit of financial engineering, all designed to get chips deployed faster.
And while those two titans are battling it out on scale, we should probably give a quick nod to Intel, right? They're trying to claw their way back into this game, pushing their new Panther Lake processors using that 18A technology.
Yeah, that 18A tech is the key thing there. It's the most advanced process node developed here in the US. Intel's really betting on it to win back market share. They're aiming for that sweet spot chips that can handle really demanding software but are still efficient enough for good battery life in devices. It's a tough balancing act.
Okay, so let's move up from the chips and data centers now to connectivity and maybe the physical world, where the cloud literally meets the sky.
Yeah.
There was a huge infrastructure deal recently, but not on the ground in orbit.
Right. SpaceX, they just finalized a massive $17 billion deal to buy spectrum licenses from EchoStar, specifically the AWS-4 and H-block spectrum, about 50 megahertz total.
17 billion. That's an astronomical price for radio waves. Is it really worth that, or is this more about blocking rivals like Amazon's Kuiper?
Oh, I think it's absolutely justified from their perspective because this spectrum is the key enabler for their next big leap. It's what potentially allows Starlink to offer services directly to standard mobile phones, bypassing the need for a dedicated Starlink dish for some things.
Ah, direct to cell.
Exactly. Phone calls, texts, eventually maybe even basic broadband, delivered globally from space to your existing phone, that instantly positions Starlink as a potential global mobile provider. It's a massive challenge to every traditional cell carrier out there.
That really does shake up the mobile landscape.
Huh?
Speaking of shaking things up, let's talk robots again. The hardware seems to finally be catching up to the AI ambitions. We got an update on Figure AI's humanoid bot.
Figure 03, yeah. It's a 5'6", about 132-pound general-purpose humanoid robot, and its big claim to fame right now, using its AI system called Helix, it can do some pretty complex, nuanced things like folding clothes, doing dishes.
So the AI war starts in the laundry room, huh? Not the factory floor. I might actually mortgage my house for a robot that can reliably pair socks.
Well, it's certainly a compelling demonstration of dexterity and applying general AI to physical tasks. They're aiming for a 2026 release, which sounds ambitious. But the contrast is interesting. While Figure AI seems to be pushing hard, there are reports that Tesla has actually abandoned its plans to build 10,000 of its Optimus robots internally this year.
Oh, really?
Yeah. It just highlights how incredibly complex and expensive it still is to take AI out of the digital realm and make it work reliably in the physical world at scale.
We are seeing that integration happen more, though. Look at Planet Labs launching their Owl satellites. They've got Nvidia chips on board. This isn't just taking pictures from space anymore.
No, it's about the speed of getting insights. By having those powerful chips right there on the satellite, they can do AI analysis of the imagery in orbit.
Ah, edge computing in space.
Exactly. They can deliver high-res, analyze information, tracking natural disasters, maybe monitoring ship movements, checking crop health within an hour, potentially. That ability to analyze at the edge so quickly, that's the real game changer there.
Okay, before we pivot to the folks actually building all this software, let's just quickly touch on a couple of amazing science breakthroughs we saw. The Nobel Prize in physiology or medicine went for the discovery of regulatory T cells.
Yeah, TREGs. These are specialized immune cells that basically act like peacekeepers in the body, stopping the immune system from overreacting or attacking itself.
Which has huge potential, right?
Massive therapeutic potential for treating everything from cancer, where you might want to dampen them, to autoimmune diseases like arthritis or MS, where you want to boost them. Really foundational work.
And also on the medical front, fantastic news about histotripsy getting FDA approval for liver tumors.
Yes. That's the technique using focused ultrasound sound waves to basically liquefy tumors non-invasively. It creates tiny microbubbles that mechanically destroy the cancer cells.
Non-invasive, non-toxic.
Exactly. It's fast, apparently non-toxic, and patients often go home the same day. Incredible stuff.
Yeah. Amazing progress. Okay, let's wrap things up by looking at the people actually building this future, the developers, and maybe some of the legal frameworks trying to keep up. There's this almost philosophical insight doing the rounds for developers, sometimes called the bitter lessons of AI development.
Yeah, this might actually be some of the most practical advice out there right now. The bitter lesson is basically this. Stop trying to engineer clever workarounds for the things current AI models can't do well. Stop trying to patch the model's weaknesses with complex code.
Okay, so what's the alternative then?
You have to pivot your product roadmap based on what the new models can do. If your current approach requires lots of hacks and complex engineering just to make the AI part functional, you should probably kill that project or feature.
Wow, that's harsh. Kill the project.
It sounds brutal, but the reasoning is that the next major model upgrade, the GPT-6, the Sora 3, whatever comes next, will likely just solve the problem you were spending all that time and effort trying to engineer around today. The core advice is, understand a model's capabilities deeply and build around those, rather than sticking to an old plan and trying to force-fit the AI.
That is tough medicine. But it definitely reflects that insane pace we started this whole conversation with.
Exactly.
On the developer community side, though, there was some good news. The React Foundation got set up, right, as part of the Linux Foundation.
Yeah, that's a positive step. Provide some stability and dedicated infrastructure support for React, which is, one of the most widely used open source projects out there. Gives the community some reassurance.
But on the flip side of open source, some worries about Qualcomm buying Arduino.
Right. Arduino is synonymous with open source hardware, the whole maker movement. Qualcomm bought them, and while they've made all the usual promises about maintaining the open source commitment,
There's always that concern.
there's always that underlying concern in the community that eventually the platform might get more locked down, or its core open source mission might get diluted by corporate priorities. We'll have to wait and see on that one.
Okay, and finally, let's touch on that huge legal battle that could reshape the digital economy. The U.S. versus Google ad tech monopoly case. The recent arguments were all about the remedy, right? Not about whether Google is guilty, but what should be done about it.
Exactly. And the proposed solutions are miles apart. The Department of Justice is pushing hard for a forced breakup. They argue the only way to fix the alleged monopoly in the software connecting ad buyers and sellers is to make Google sell off parts of that ad tech business.
So just to simplify this legal stuff for you listening, the government wants major surgery, a forced separation of business units. What's Google's counter-argument?
Google's fighting that surgery idea. They're saying a breakup would be incredibly complicated, disruptive, and ultimately harm publishers, the websites that relied on ad revenue. Their proposal is much softer. Basically, they're offering to make their existing systems work better with competitors' tools. They're proposing internal adjustments and improved interoperability rather than being forced to sell off key parts of the business. So the judge has this choice: mandate radical surgery or try to enforce better behavior within the existing structure. Big decision pending there.
Man, this has been quite the tour.
Yeah.
From the race to build the AI operating system, OpenAI really pushing, Google defending, to the absolutely staggering scale of the hardware investments, like that $20 billion XAI deal and the 6 gigawatt AMD partnership.
And all the way to the push into the physical world, Starlink going direct to mobile, those figure robots folding clothes.
That covers so much ground.
I think the key takeaway really is that these foundational decisions happening right now, which chips get bought, how they're paid for, which protocols manage access, the rules governing distribution, these things are setting the stage. They're going to determine what technology looks like for the next decade easily. These are the claims being staked for future control and influence.
Okay, so building on that, here's a final provocative thought for you to chew on. Given those bitter lessons of AI development, we talked about the advice to basically kill old projects and wait for the next big model upgrade because it'll solve today's problems.
Yeah.
How long does that make the lifespan of these massive infrastructure investments, like that 550,000 chip Colossus 2 data center? If the next generation of models is radically different or more efficient, how quickly does today's bleeding edge become, well, obsolete?
Right.
What's the real shelf life of tens of billions of dollars of hardware in this environment?
That's a really good question. A multi-billion-dollar question, literally.
Something to think about. Thanks for joining us for this run through of the material. We'll catch you next time.
Spoken Tech for your ears.